you're proving that left-hand side does not equal right-hand side. But rather than showing you the false case, I'm just going to show you the true case. Okay, so to develop an identity for sine 2a, we're going to use the sum identity for sine a plus b. So explain how the sum identity for sine a plus b can be used to determine the identity for sine 2a. Basically, we're going to show that sine 2a can be rewritten as sine a plus a. Okay? A plus a is equal to 2a. So here, now we can apply the sum identity for sum. So sine a plus a is equal to, and we're going to apply the sine identity, I'll just write it underneath. So sine a plus b is equal to sine a cosine b plus sine, plus cosine a sine b. So what's the difference? What are the b's now?
A's.
They're just a's. So we're just going to switch these with a's. Okay, do these look the same to you? Okay, let's pretend these are pencils. We have one pencil, two pencils. So in result, we have 2 sine A, cosine A, 2 pencils. So we've proven that sine 2A is equal to 2 sine A times cosine A. Okay, and this identity is also on your formula sheet. Okay, and I've written it up here for you. Let's prove the double angle identity for cosine. How can I rewrite cosine 2a? Good, cosine a plus a. Well, if I were to write it as b, like we see on the right hand side, we'd have cosine a, cosine b, minus sine a, sine b. But what are b's this time? They're a. Okay, we have a plus a. So all these b's just need to change to a's. And then we multiply through. Cosine a times cosine a is cosine a squared. And sine a times sine a is sine a squared. Therefore, cosine 2a gives us the identity of cosine a squared plus sine a squared. Sorry, minus sine a squared. Now, I'm just going to point out on the right board, cosine's unique because it has 3 double angle identities. Okay, sine only has 1 and tan only has 1, but cosine has 3. So if you just take a look here, cosine 2a can be cosine a squared minus sine a squared. Cosine 2a can be 2 cosine a squared minus 1. And the last one would be cosine 2a is 1 minus 2 sine a squared. These are all just the rearranging of the Pythagorean theorem, or the Pythagorean identities. So just keep in mind, if you have a cosine 2a identity, you might have to play around a little bit on which one you will use. Okay? It works for all 3. Do you guys think we need to go through proving the double angle identity for tan? Yeah? Okay. So tan 2a can be rewritten as tan a plus a. And we just have to apply the sum identity for tan now. So looking at the board over here, this is our tan identity for sum. Okay, so instead of b, what do we have? A. Okay, so we'll just plug those in. Tan a plus tan a over 1 minus tan a times tan a. So that gives us 2 tan a over 1 minus tan a squared. And this is the double angle identity for tan. Okay, to summarize, on the next page you have all the double angle identities. So first question, we need to prove that left-hand side equals right-hand side. To prove that 2 tan x over 1 plus tan x squared is equal to sine 2x. And then we have to state the non-permissible values like we did yesterday. So always separate it. Let's do our left-hand side first. And then we'll compare it to our right-hand side. And our right-hand side we don't have much work because it's pretty simple, so I'm just going to leave it first. Let's start with the most complex side. 2 tan x over 1 plus tan x squared. Do you guys remember from the Pythagorean identity what we could rewrite 1 plus tan x squared as? So 1 plus tan x squared is equal to secant x squared. Okay, that's on your formula sheet. And then in the numerator, we can use the quotient identity. Okay, that tan x is equal to sine x over cosine x. So there's 2 identities that we can apply here. Maybe just write it up here. Okay, so we have 2 sine x over cosine x in the numerator. And in the denominator, we'll have secant x squared. So I've applied the quotient identity to tan to give me sine over cos. And 1 plus tan x squared using the Pythagorean identity gives me secant x squared. Okay, using the reciprocal identity. What's the reciprocal of secant? Cosine. We get 1 over cosine x squared. And I don't want to have a fraction over a fraction, so I'm just going to multiply by the reciprocal in both the denominator and numerator. So multiplying by cosine x squared over 1 in the denominator, and multiplying by the same thing in the numerator. Denominator cancels out completely. So we're left with 2 sine x over cosine x multiplied by cosine x squared. You guys see anything that could cancel out? Yeah, one of the coses, or cosines. So we have 2 sine x times cosine x. And this happens to be a double angle identity. For sine. So last step, this will become sine 2x. What did the right hand side equal? Sine 2x. Do we have to do anything to it? No. Left hand side equals right hand side. Shows where you at? So from here to here?
Yeah.
So 2 sine x cosine x, it happens to be a double angle identity. It is the right hand side here. But instead of a's, we have x's. So if we have 2 sine x cosine x, I can write that instead as 2 sine x. This is equal to that. So it can be written
Wait, so
either
do we
way.
get those formulas?
Yeah, you're provided these.
Okay.
So I really suggest you get a lot of practice with these, because if you don't practice them, you're probably not even going to think to look,
Yeah.
or you're going to be searching forever. So please make sure you practice a lot with these ones. anyone know where Nolan is? Yeah. No idea. Sorry about that. Thanks, bye. Okay, so we're going to use the identity that sine 2a is equal to 2 sine a cos a. That's the double angle identity for sine. Okay, and we're going to replace a with 3x to determine the double angle identity for sine 6x. So let's just start with the sine 2a. A will instead be 3x. So we're just working on the left-hand side first. Sine 2 times 3x gives us sine 6x. So now we just have to figure out what is the right-hand side. We have 2 sine 3x, cosine 3x, and there's nothing else we can do. So maybe I should just write it as sine 6x equals that. Do you have a question? Okay, now let's write double angle identities for our cosine 10a. So I'll just remind you guys, cosine 2a, there's 3 of them, so you could actually choose whichever one you wanted. I'll just use the top one, cosine a squared minus sine a squared. So as you can see, we need a 2 for it to be a double angle. So what would a be equal to from 10a if we had to have a 2 out front? 5a. Okay? So we have cosine 2 times 5a. So on the right-hand side, what are all the a's going to be replaced with? 5a. Good. Okay, so we have cosine 5a all squared minus sine 5a all squared. And we're done.
Junior class change.
Okay, next little bit, tan x. We need to write that as a double angle identity. We don't have a 2, so we need to make a 2. So if I just magically put a 2 out front, what do I have to do to that x? So if I'm multiplying by 2, to undo that, I need to divide by a 2. Okay, and I'll just remind you guys of the double angle identity for tan. Might have to remind myself as well. So tan 2a is equal to 2 tan a over 1 minus tan a squared. From above, what was a? X over 2. So we're just going to replace all the a's with x over 2. So we get 2 tan x over 2 all over 1 minus tan x over 2 squared. Okay, the last little bit. We have to express each of the following as a single trig function. So if you were to look at your double angle identities, does this come from sine, cosine, or tan? Sine. Sine 2a equals 2 sine a cosine a. So what will a be replaced with? 4x. So this is going to be equal to sine 2 times 4x. And if we simplify further, we get sine 8x. Okay, next one. Do we see a double angle identity? Sine, cosine, or tan? Cosine. So cosine 2a is equal to cosine a squared minus sine a squared. What's the a in this case? 1 over 2a. Good. So then we end up with cosine 2 times 1 over 2a. 2's cancel out, and we get cosine a. Next one, you have to be a little bit creative. Which double angle identity looks most similar to this? Sine, cosine, or tan? Sine. But what's it missing in front? 2. So if I want to put a 2 in front, so I'll just start again. If I want to put a 2 out front, what else do I need to put out front? If I multiply by 2, I also need to divide by 2. Okay, so the half's going to stay out front. And just referring to this double angle identity again, sine 2a equals 2 sine a cosine a. So this will become sine 2 times our a, which is 5x over 2. 2's cancel out, so I get half of sine 5x. Voila. Please make sure you practice these, guys. If you just let it slip by watching me, you're not going to get it, okay? So you will have to put in the practice, put in the time.